In this section, we try to understand permutation and combination in great depth. Alright, now what do we mean with permutation and combination? These are just tools that help us to count the number of ways in which something can be done. Let's try to understand it in greater depth. Alright, I denote permutation with P and combination with C. Now let's take an example. I have three friends over here. That's hen, broccoli and bee. Now out of these three friends, you need to select a captain and a vice captain. Alright, let me mark the position for the captain and vice captain over here. Now in one particular way of doing this, I have hen as the captain and broccoli as the vice captain. In another way of doing this selection, I have broccoli as the captain and hen as the vice captain. Now we need to ask ourselves whether these two ways of selecting a captain and vice captain are the same or different. Over here you have hen and broccoli. Over here also you have hen and broccoli, right, in these two instances. But you will see that in instance 1, hen is the captain, and in instance 2, it's broccoli that's the captain. So you will agree with me that these two ways of doing this selection that we talk about are different, right? And it is in these type of cases that we use permutation. Alright, we go on building an intuitive understanding of the same. Let me keep this aside. Alright, now let's take another example. Say we have three teams. We have India, we have USA, we have Germany, for example. And from these three teams, you need to arrange football matches. Alright, now say in one way in which I want to arrange a match is India versus USA. Another way is USA versus India. Now let's ask us the same question that we asked over here. Are these two instances the same or different? Over here also you have India and USA. Over here also you have USA and India, right? Now you will agree with me that these two are the same, right? India playing USA and USA playing India, both are one and the same. It is in these type of instances that we use combination. Alright, we are moving ahead building an intuitive understanding of combination and permutation. Let's keep this aside. Alright, now you will see that in this case where we had to select a captain and a vice captain, the order is important, right? Having the hen over here and having the hen over here makes a huge difference, right? So the order in which the items are arranged is important. But what about in this case? We can see that the order is not important. If I mention the game as India versus USA or USA versus India, it's one and the same. Therefore, the order is not important, right? Alright. Now, you will notice that in the case of permutation, selection and arrangement is involved. That is, out of these three friends, in one instance, we selected two friends. That is, we selected the hen and we selected broccoli. That's selection over here. And after doing the selection, we arranged them in the positions of captain and vice captain. Over here, we have hen in the position of captain and we have broccoli in the position of vice captain. And in the second instance that we have written over here, we have broccoli as the captain and hen as the vice captain. So permutation involves selection and arrangement, and that's because order is important. That is why arrangements of the same items in two different ways actually give us two different results. In the case of combination, that's what we have seen over here, only selection is involved, right? We have seen that placing India first and writing the match as India versus USA, and placing USA first and calling the match as USA versus India does not make any difference. Both are one and the same. Therefore, whenever combination is involved, only selection is what we do. We have seen that in the case of permutation, selection and arrangement is involved, and in the case of combination, it's only selection. Alright, before we move ahead with P&C, let's take a quick side note to understand what we mean with factorial, because we'll be using that a lot when we go ahead. Alright, say you want to find 5 factorial. Let's take this example to understand factorials. what do I mean with 5 factorial? 5 factorial is denoted like this, right? 5 followed by an exclamation mark. You could also denote it like this, 5 with this type of a symbol. All right. Now 5 factorial means it's the product of numbers from 1 to 5. That is, it's 5 into 4 into 3 into 2 into 1. That's 5 factorial. And if you do this multiplication, you will get the answer as 120. So 5 factorial is equal to 120. Now, using this, we can generalize it as n factorial is the product of the numbers from 1 to n. That is n into n minus 1, etc. up to 1. Now, an interesting thing to note in the case of factorials is that 0 factorial by definition is defined as 1. So 0 factorial is by definition 1. Let me write that, it's by definition. Alright, let's take one more example. Say you want to find 6 factorial. What would that be? That's equal to 6 into 5 into 4 into 3 into 2 into 1. That's equal to 720 if you do the multiplication. You will also note that this is nothing but 6 into 5 factorial, right? And we know that 5 factorial is 120 from here. So that's 6 into 120, which also gives you the answer as 720. Let's come back to the case where we had 3 friends and we had to select a captain and a vice captain from these 3 friends. Alright, let me mark the position of the captain and vice captain over here. Now, let's write all the ways in which this can be done manually. Say I choose A and B and I arrange them in the position of captain and vice captain. Or I could choose A and C and arrange them in the 2 positions. Or I could choose B and C and arrange them in the 2 positions. Is there any other way in which this can be done? No, there is no other way, right? So there are 6 ways in which we can choose a captain and a vice captain from these 3 friends. Now, it's not always time consuming to write it out like this and count, right? We have seen that permutation and combination are tools that help us count, right? Now, in this type of scenarios where order is important, we have seen we use permutation. Now, this can be written in terms of permutation as 3p2. If we say 3p2, it means select 2, that is the 2 over here, from 3, that's the 3 over here, and arrange them among themselves. That is, from 3 friends, we have to select 2 friends and arrange them among themselves. That's what we call 3p2. Alright, now let's introduce the formula for permutation. Say we have a generic statement that's NPR. NPR is expanded as n factorial divided by n minus r factorial. Now, let's apply it in the case of 3p2. That would be n is 3 and r is 2, right? So 3p2 is equal to 3 factorial by 3 minus 2 factorial, which gives 3 factorial by 1 factorial. We have seen that 3 factorial is 3 into 2 into 1. That gives us 6, and 1 factorial is just 1. So 6 by 1, it gives us the answer as 6. And that's the 6 that we got over here. So 3p2 is nothing but selecting 2 people from 3 people and arranging them among themselves. Remember, over here we used permutation because the order is important. That is, a case where A is the captain and B is the vice captain is different from a case where B is the captain and A is the vice captain. In this video, let's discuss the case where we had 3 teams and we need to organize all the possible games between them. Alright, what are the possibilities? I could have A play with B, right? That's these 2 guys playing. What else? I could have A play with C, right? That's these 2 guys playing. What else? Is there any other possibility? Yes, I could have B play with C, right? That's this possibility over here. Is there any other match that can be organized? No. You will see that only 3 possibilities are there. That is, 3 matches can be organized. Now, we could count these type of scenarios manually. Like this is 1, this is 2, this is 3. But in these type of cases, to make our counting easier, we use a tool called combination. Remember, permutation and combination are just tools that help us count. Now, over here, we have discussed before that writing a match as A versus B and writing the match as B versus A does not make any change, right? Both these scenarios are one and the same. That is, order is not important, right? Now, when order is not important, we use the tool called combination. So I could do this in this way manually, or I can find this as 3C2. Now, what does 3C2 mean? It means the number of ways in which we can select two items from three items. The 2 over here is the 2 that you have over here, and the 3 over here is the 3 over here. So 3C2 is nothing but the number of ways in which two items can be selected from three items. Alright, now what's the formula for NCR? Let's find that out. NCR is equal to n factorial divided by r factorial into n minus r factorial. Alright, now let's apply this in the case of 3C2. So that would make n as 3 and r as 2. Let's apply that over here. We get 3 factorial divided by 2 factorial into 3 minus 2 factorial. And on expanding, we get that as 3 factorial by 2 factorial into 1 factorial. 3 factorial is 3 into 2 into 1. 2 factorial is 2 into 1 and 1 factorial is just 1. Now on simplifying this, you will get the answer as 3. And that's the 3 that we got over here. So NCR is the ways in which R items can be selected from N items. And remember, over here we used combination because the order was not important. A match, if you write it as A versus B, or if you write it as B versus A, are one and the same. Therefore, the order is not important. That's why we used combination in this type of a scenario. In this video, let's summarize what we have learned so far in permutation and combination. For that, let's compare between permutation and combination. What's the notation for permutation? It's NPR, right? And what is the notation for combination? It's NCR. Alright, what's the meaning of NPR? It's the number of arrangements of n things taken R at a time, right? Or it means the number of ways in which you can take R things from n and arrange the R things among themselves. What's the example that we have seen? We have seen the number of ways in which we can take two friends from three friends and arrange them in the position of captain and vice captain. Alright, what does NCR stand for? It's the number of selections when R things are taken from n things, right? And what's the example that we have seen? We have seen the case where we had to select two teams from three teams so that we organize games between them. Alright, now when do we use permutation? It's used in cases where order is important, right? If we have to count anything where the order is important, we use the tool called permutation. Similarly, when order is not important, we use combination. Alright, what's the formula for NPR? We have seen that it's equal to n factorial divided by n minus r factorial, right? And what is the formula for NCR? It's equal to n factorial divided by r factorial into n minus r factorial. Alright, you can see that these two formulas are pretty similar. The only difference is that in the case of NCR, you have an extra r factorial in the denominator, right? Now, which do you think will be greater? Say if you have 3p2 and if you have 3c2. Among these two, which one will be greater? It's definitely 3p2, right? Because over here the denominator is greater. So if you have the same number like 10, right? If you divide it with 2 and if you divide it with 5, this will be greater, right? 10 by 2 gives you 5, 10 by 5 gives you only 2. That's because the denominator is greater. Similarly, over here the denominator is greater. Therefore, if you compare 3p2 and 3c2, 3p2 will be greater. So these are just ways in which you solidify your understanding of permutation and combination. In this video, let's practice calculating NCR and NPR. Alright, let's start with calculating 5c3 and 5c2. Remember, NCR is equal to n factorial divided by r factorial into n minus r factorial, right? All right. So what would be 5c3? That's 5 factorial divided by 3 factorial into 5 minus 3 factorial, which is equal to 5 factorial by 3 factorial into 2 factorial. All right. Now let's calculate 5c2. That's over here. That's equal to 5 factorial by 2 factorial into 5 minus 2 factorial, which is equal to 3 factorial. All right. Now you will see that these two are one and the same, right? You have 5 factorial in the numerator and you have 3 factorial into 2 factorial in the denominator. So these two are one and the same. Therefore, we can conclude that 5c3 is equal to 5c2. Now, in which cases does this happen? Over here, you can see that you have 3 and you have 2. If you add these two together, that's 3 plus 2, that is equal to 5, which is what you have over here. Let's keep that aside. So, in any case where you have this type of a combination, the two will be the same. So, can you say that 10C7 will be equal to what? Over here, it's 5 and over here also it's 5, right? So, I should have 10C something is equal to 10C7. And over here you can see that 3 plus 2 is equal to 5. So whatever you have over here plus 7 should give you 10. So we know that 7 plus 3 is equal to 10. Therefore 10C7 is equal to 10 minus 7, right? Which is equal to 10C3. So 10C7 and 10C3 will give you the same answer. What about 23C19? That will be equal to 23C4, right? Because 9 plus 4 is equal to 23. Alright, now let's try to solve 23C4. We know that NCR is equal to n factorial divided by r factorial into n minus r factorial, right? Alright, now let's try to solve 23C4. Now over here, instead of solving it like this, to do it in a faster manner, you just need to check what you have over here. That's 4 over here. So starting at 23, keep subtracting 1 and write the numbers such that you have 4 numbers. So that's 23, 22, 21 and 20. So that's your numerator. If you multiply the 4, and in your denominator you will have 4 factorial. That's what's coming over here. 4 factorial is 4 into 3 into 2 into 1. So 23C4 is equal to this expression over here. If you solve it, let's try to solve it. You can cut out 4 both from the numerator and denominator. You're left with 5. Similarly, you can simplify this. 21 by 3 will give you 7. 22 by 2 will give you 11. And 1 remains as it is. So that's 23 into 11 into 7 into 5, which is equal to 8855. Therefore, 23C4 is equal to 8855. Alright, let's do one more question. What about 19C17? So the first step is make it into a simpler expression. We know that 19C17 will be equal to 19C2, right? Because 17 plus 2 is equal to 19. Alright, so 19C2, that's 19 into 18 by 2 factorial, which is 2 itself. Now, why did you just take 2 numbers in the numerator? Because that's what you have over here, which is a 2. Alright, let's do some more questions. Say we do these 3 questions: 27C20, 9C7 and 11C3. Alright, what do we start over here with? We have 27C20. So this will be equal to 27C7, right? Because 20 plus 7 is equal to 27. Now the numerator will be 7 numbers starting with 27 and you keep subtracting 1. And the denominator will be 7 factorial. So this is equal to 27 into 26 into 25 into 24 into 23 into 22 into 21. So that's 7 numbers by 7 factorial, right? What about 9C7? 9C7 is equal to 9C2, right? And in the numerator you will just have 2 numbers, that's 9 into 8 divided by 2, right? What about 11C3? In the numerator you have 3 numbers, that's 11 into 10 into 9 divided by 3 factorial, which is equal to 6. So in this way you will be able to quickly solve these type of expressions, right? So what's 9C7? That's 9 into 4, which is 36, right? Similarly, what's 11C3? that would be 15 into 11, right? That's 165. All right, let's do some more questions. Say we want to find 7p3. Remember, what's the formula for npr? It's equal to n factorial by n minus r factorial, right? All right, so 7p3 as per the traditional formula that we have written over here would be 7 factorial divided by 7 minus 3 factorial, which is equal to 7 factorial by 4 factorial, right? And over here, if you expand 7 factorial, you will get 7 into 6 into 5 into 4 into 3 into 2 into 1, right? And 4 into 3 into 2 into 1 is equal to 4 factorial. So 7 factorial can be written as 7 into 6 into 5 into 4 factorial. You cancel out the 4 factorial in the numerator and denominator, and you get your answer as 7 into 6 into 5. All right. Now, how do we do this faster? Over here, we check that we have a 3 over here, right? So your answer is the product of 3 numbers starting with 7, and you keep reducing the numbers by 1. That is 7 into 6 into 5. That's the same thing that we got over here. All right. So what would be 10p4? That would be 10 into 9 into 8 into 7, right? We have 4 numbers over here because that's what we have over here. What would be 12p2? That would be 12 into 11. We have 2 numbers over here because that's what we have over here. What would be 15p4? That's 15 into 14 into 13 into 12. 4 numbers over here because we have a 4 over here. Let's do this question. In how many ways can 11 players be selected out of a pool of 20 players to form a team? Now pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. In this question, we just need to select the players to form a team, right? So the question only involves selection, and whenever we have just selection, the tool that we use is combination, right? Because combination is used for only selection and permutation is used in the cases where you have to select and arrange the selected items. So in this question, we need to select 11 items from 20 items or 11 people from 20 people. That's equal to 20C11, right? And we know NCR is equal to n factorial by r factorial into n minus r factorial. So 20C11 is equal to 20 factorial divided by 11 factorial into 20 minus 11 factorial, which is equal to 20 factorial by 11 factorial into 9 factorial. And you can simplify this in this manner. 20 up to 12 is multiplied in the numerator and 9 factorial is in the denominator. If you simplify this, you will get the answer as 167960. And in many cases, the options in the question will not ask you to find this answer. There might be options like this. Like you could have an option as 20C11. Another option can be 20P11, etc. You could have these type of options. So in that case, you don't need to calculate this. Otherwise, the numbers involved will be in many cases easy to calculate. And remember, 20C11 is equal to 20C9, right? And in that way, you can directly write this expression over here. That's in the numerator, you have the numbers starting with 20, you keep subtracting 1 and you need to have 9 numbers, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 numbers in the numerator, and the denominator is equal to 9 factorial. That is 9 into 8 up to 1. And that's the answer to this question. Let's do this question. In a room, there are 20 people. Everyone shakes hands with every other person exactly one time. Find the total number of handshakes. Alright, pause the video, give it a try, and then we'll do it together. Alright, we are back. I hope you have given it a try. In this case, we just need to find the number of ways of selecting 2 people from 20, right? Because we have given that every person shakes hands with every other person exactly one time. So say you have a simpler problem. If you have just 3 people, right? How many handshakes will occur over here? Between these guys, you will have one handshake. Between these guys, you will have one handshake. and between these guys you will have one handshake, right? And that's nothing but the number of ways of selecting two people from three people. Similarly, in this case, to find the answer, you just need to find the ways in which you can select two people from 20. Now over here only selection is involved, right? We don't need to arrange the two people. If I am selecting person A and person B, it's the same as selecting person B and A. This is the same, right? Order is not important, or this is a question where only selection is involved. So that's equal to 20C2, and 20C2 is 20 factorial by 2 factorial into 18 factorial. That's equal to 20 into 19 by 2, and over here you can cancel out 2, and 19 into 10 gives you 190 as the answer. And remember, you don't need to do it like this. You can directly solve it as 20C2. You have 2 over here, so you need to have two numbers in the numerator. That's 20 into 19 divided by 2 factorial. That's the same thing that you got over here. So applying that, you can reduce the process by one step and your answer is equal to 190. Let's do this question. On a sheet of paper, there are 12 points, of which no 3 points are collinear. How many straight lines can you form? Pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. In this case, an interesting thing to note is, when do we say that points are collinear? It means that they are on the same line. So if I have a straight line over here, and if I take 3 points on this straight line, let this be point A, B and C, then we can say that these 3 points are collinear. Alright, now over here we have 12 points and it is mentioned that no 3 points are collinear. Alright, therefore to find the number of straight lines that we can form, we just need to find the number of ways of selecting 2 points at a time. And over here only selection is involved, right? Whether I select 2 points over here, say I have point A, B, C all over here in this plane. If I select the point A and B, or if I select the point B and A, it does not matter, right? I still get the same line. Therefore order is not important. That is, I just have to do selection. I do not have to do arrangement. So the tool that we use is combination, right? Now we need to find the ways in which we can select 2 points from 12 given points. That's equal to 12 C2, and we can solve this as 12 into 11 by 2, which gives you the answer as 66. Remember, you don't need to do this step over here, right? From 12C2 directly you can find that it's equal to 12 into 11 by 2, because you have 2 over here. So in the numerator you will have two numbers starting with 12 and you keep subtracting 1. That's 12 and 11, and the denominator is 2 factorial, which is equal to 2. So 12C2 is 12 into 11 by 2, which gives you the answer as 66. Let's do these two questions. On a sheet of paper, there are 12 points, of which 5 points are collinear. Alright, how many straight lines can you form? And the second question is, on a sheet of paper, there are 12 points, of which 5 points are collinear. How many triangles can you form? Alright, pause the video, give it a try, and then we'll do it together. Alright, we are back. I hope you have given it a try. So we have these two questions. Let's start with the first question. 5 points are collinear and we need to find the number of straight lines that can be formed. Alright, now if I need to find the number of straight lines that can be formed, first I just need to select 2 points from the 12 points, right? That's 12C2, but I have to subtract the cases where 2 points from the 5 collinear points are selected, right? Why is that so? Say these are the 5 collinear points, right? Now if I select these 2 points, or if I select these 2 points, or if I select this one and this one, I always get the same line, right? Now if we just do 12C2, it's considered that taking these 2 points or taking these 2 points are different cases. But over here, because the points are collinear, if I select these 2 points, I get the same straight line. If I select these 2 points, I get the same straight line. And remember, a straight line has no ending. So if I select these 2 points, the straight line does not end with here. it keeps going on in both the directions. Therefore, if I select these 2 points or these 2 points, the straight line that I get is the same. That's why, to avoid double counting the same straight line, we have to subtract the cases where 2 points are selected from the 5 collinear points. Is that it? No, we have to add 1 to this, right? Because from the 5 collinear points, we still get one straight line, which is the straight line over here. Therefore, the answer to this question is 12C2 minus the cases where 2 points from the 5 collinear points are selected plus 1. And remember, this 1 over here is the one line that can be formed using the collinear points. Therefore, the answer is 12C2 minus 5C2 plus 1. What is 12C2? That's 12 into 11 by 2. What is 5C2? It's 5 into 4 by 2, right? Therefore, the answer is 12 into 11 by 2 minus 5 into 4 by 2 plus 1, right? And what's that equal to? This is equal to 57, which is your answer. All right. Now, let us keep this aside and we'll do the second part of this question. Over here, we need to find the number of triangles that can be formed, right? Now, to form a triangle, you need 3 points, right? Because a triangle has 3 vertices. Say this is triangle ABC. Point A, point B and point C are 3 vertices. Now, if you have collinear points, these are my 5 collinear points. If I select 3 points from these 5 collinear points, I cannot form any triangle, right? If I, for example, if I select these 3 points, using these 3 points, because they are in the same straight line, I won't be able to form a triangle. Therefore, the answer to this question is 12C3, which is the number of ways of selecting 3 points from 12 points minus 5C3, which is the cases where 3 points are selected from the 5 collinear points. And I have to subtract this because, as we discussed over here, if I select 3 points from the 5 collinear points, I will not be able to form any triangle. Therefore, the answer is 12C3 minus the violating cases, which is 5C3. 12C3 is equal to 12 into 11 into 10 by 3 factorial or 6 minus 5C3 is 5 into 4 by 2. Why is that? Because 5C3 we know is equal to 5C2, because 3 plus 2 is equal to 5, and 5C2 I can solve it as 5 into 4 by 2, right? So that's the answer to this question, and we can simplify this. 6 gets cancelled from the numerator and denominator. So over here you have 22 into 10, which is 220, minus 5 into 2, which is 10. So 220 minus 10 gives you the answer as 210. Let's do this question. Find the number of diagonals of a polygon with 13 vertices. Pause the video, give it a try, and then we'll do it together. Alright, we're back. I hope you have given it a try. Let's do it together. Now, a polygon is a simple closed curve where all the sides are straight lines. So in simple terms, if you have a shape like this is a hexagon. Over here you have 6 vertices, and this is an example of a polygon or a square. This is a polygon with 4 sides, 4 vertices, and if you have a polygon with 5 sides, for example, this is a pentagon. Over here you have 5 sides and 5 vertices. Now, when do you get a diagonal of a polygon? If you join 2 non-adjacent vertices, right, you get a diagonal. For example, these 2 vertices over here are not adjacent. When you join them together, you get a diagonal. Similarly, if you join these 2 together, you will get another diagonal. Over here, in the case of a pentagon, if you join this vertex and this vertex, you get a diagonal because they are not adjacent to each other. Alright, now in this question, we need to find the number of diagonals of a polygon with 13 vertices. Now, over here, to solve this, we just need to find the lines formed by 13 points which are not collinear, right? Over here, you can notice that there are no 3 collinear points in the case of any polygon. 2 points are collinear, like, of course, you can create one line when you just take 2 points. Alright, now from this, from all the possible lines that you can form from the 13 vertices, you need to subtract the sides, right? Because say you have a quadrilateral over here. Now, if you find all the lines that can be formed by 4 points, in the case of a quadrilateral, that will be 4 points. You will not only get the diagonals, but you will get the sides also, right? Because say you're selecting this point and this point, you will get this line which is a side, which is not a diagonal. Therefore, you need to find all the lines that can be formed from 13 points, of which no 3 points are collinear. That means over here non-collinear means no 3 points are collinear. All right, it's not about 2 points. All right, and from that you need to subtract the sides. Now this can be solved as 13c2 minus 13, right? Because when you have 13 vertices, you will have 13 sides. Over here you can see you have 4 vertices, you have 4 sides. Or in the case of a hexagon, you have 6 vertices and you have 6 sides. So in the case of 13 vertices, you will have 13 sides. So the answer to this question is 13c2 minus 13. And 13c2 we know is 13 into 12 by 2. So the answer is 13 into 12 by 2 minus 13, which gives you 65. You can simplify this in this manner. 13 into 6 minus 13. You can take 13 out. 6 minus 1, that's 13 into 5, which gives you the answer as 65. Let's do these two questions. If there are 12 straight lines on a sheet of paper, find the maximum number of points of intersection that can be formed. The second one is, if there are 12 circles on a sheet of paper, find the maximum number of points of intersections that can be formed. Alright, pause the video, give it a try, and then we'll do it together. Alright, we are back. I hope you have given it a try. Let's do these two questions together. We start with the first question. We have 12 straight lines on a sheet of paper, right? Now, we need to find the maximum number of points of intersection. That will be 12c2, right? It's just about finding the maximum ways in which you can select 2 lines from the 12 lines. Now, when you select 2 lines from the 12 lines, they will intersect in 1 point, right? 2 straight lines can only intersect in 1 point. There is no way that 2 straight lines intersect in 2 distinct points. That's not possible. So in every one of these cases, there will be 1 intersection point. So the maximum that can be obtained is 12c2 into 1, which is the same as 12c2. And what would be the minimum? The minimum would be 0. If all the 12 lines are parallel, they will not intersect, and the minimum number of intersections that can be formed is 0. So the answer to this question is 12c2, which is the maximum number of intersections that we can obtain from 12 straight lines on a sheet of paper. Alright, let's move to the second question. Over here we have circles, and we need to find the maximum number of intersections that can be formed. The answer to this will be 12c2 into 2, right? Because say 2 circles are intersecting, you can see that they intersect at 2 points over here. So to get the maximum over here, we assume that every circle will intersect with every other circle, and after that we just need to find the ways in which we can select 2 circles from the 12 circles, which is 12c2, and in each of these cases there will be 2 intersection points to get the maximum. So that's into 2. So the answer is 12c2 into 2. Remember, what is 12c2? It's nothing but 12 into 11 by 2, which is equal to 66, right? So the first answer over here is 66, and the second one over here is 66 into 2, which is equal to 132.